so today we are going to focus on solving exponential and logarithmic equations. So we have an equation, we want to solve for x, or whatever variable is given. Some things that we want to recall that will be helpful for us in solving is that if I have the same base to an exponent and I know that they're equal, I can set their exponents equal to each other. Likewise with logs. Also, we want to recall that if I have a base of an exponential set to the exponent of a log with the same base, that in this case would equal x. Same thing here. If I have log base a of a to the x, well, really, I can kind of show why this is true if you want. Sure. Really, I can use my exponent property by multiplying this in front. This right here we know is 1, so that's why that equals x. Okay, so let's solve for x here. There are many approaches. Let's have you guys see which approach you want to take. Okay? Go ahead, put me on pause. Okay, so think about this. 1, I could convert this to a log, and then I would get 3. Or I could just identify, well, 3 to what power is 27? Well, 27 is 3 cubed. Since these both have the same base, x is 3. So a couple ways to think about that. Let's have you guys solve for x here. Really similar. Go ahead, put me on pause. Here's just one way I did it. Maybe you just looked at this problem and you're like, oh, duh, x is 2. That's fine. You probably don't need to show work for this. But I know that 4/9 is the same thing as 2/3 squared, so x is 2. Next example. I'm going to have you guys try this one on your own. As a hint, I would use the difference, or I guess it's called the quotient property of logs first, and then convert to an exponential. Go ahead, put me on pause and solve. I use that quotient property to rewrite this difference of logs as a quotient. Then I convert it to exponential form. So the base of the log was e, so I got e to the 0 is x over 5. However, we know that e to the 0 is 1, so x equals 5. We want to be careful for, which doesn't apply in this problem, but since we have, for example, a natural log of x, or if we had any log of x, we would want to make sure that we check for extraneous solutions. What would be extraneous? Well, anything that makes the log negative, right? So since this is positive, we're in the clear. All right, solve for x. Go ahead, put me on pause. Log of 4 is x. How did I get that? A couple ways. I could take the natural log of both sides. That's what it would simplify to. Or I could just convert to a log form, and I get the same thing. You do not need to round this. I don't want you to. Keep it exact. Let's have you guys solve this guy here. Exponential form, I got 5 to the negative third power is x, which that's the same thing as 1 over 5 cubed, which 5 cubed is 125. So I get x is 1 over 125. Let's have you guys try this one. X is equal to log base 5 of 16. If the directions had asked to round to 3 decimal places, then I would have wanted this answer here, which you could use your change of base to get this if you don't have a newer calculator. But if it did ask in the directions for an exact answer, I would just leave it like this. Let's try another. Go ahead, put me on pause. Again, I started by dividing by 8, then I converted to log form. So if it asked for an exact answer, I'd leave my answer as 6 minus log base 3 of 5, which there's multiple ways I could write this. You can change of base if I wanted to, like if it said using natural logs in your answer, but it doesn't specify here. If it had said round to 3 decimal places, this would have been my answer. Last one. Again, let's have you guys try this one. Okay, so I have log base 9 of 4 plus x and log base 9 of 2x minus 1. Since these are both log base of 9, it's not necessarily that they cancel. A lot of people just do this. Like, that's not actually what's happening. It's not like I'm dividing both sides of log base 9. what's actually happening in this problem that allows us to set these equal to each other is that we could put both sides to a base of 9. Well, if I have 9 to the log base 9 of this equals 9 to the log base 9 of this, well, I know that this part on the left side here is 4 plus x, and this is 2x minus 1. So that's truly what's happening. Again, it's not like we're just canceling out the log base 9, because that doesn't stand alone. I get x equals 5. Just as a last reminder, double check, if I were to plug this back in to the equation, would it make any of these logs negative? We want to make sure that we don't have any extraneous solutions. This would be positive, this would be positive, so we're good on this answer. Okay? So, in conclusion, just make sure when we are solving exponential equations, isolate the exponential, convert to a log, and then take the log of both sides using a property. When we're solving for logs, make sure that we isolate the log if possible, rewrite as an exponential, and then we can use properties. Last thing that I want to remind us is to check for extraneous solutions. And hopefully you guys were listening and heard what would be extraneous. Good job.